Okay, let's start with regression analysis. Today we will discuss about regression analysis. Regression analysis is a statistical technique. Basically, it is a dependence technique. So dependence technique means in this kind of techniques, in this kind of analysis, one can easily understood the dependency of one variable with respect to other variable. So in the common sense, we can say if we want to examine impact of x on y, so we can make the regression analysis y equal to v plus x, where x is dependent variable while x is independent variable. So in this kind of test or this kind of analysis, we are trying to understand the dependence of x on y. X on y. Regression analysis is basically a technique used to build models for largely for two types of purpose. Number one, to understand the impact of, to study the dependency of one or more variable on predicted or criterion or outcome or dependent variable and second thing is for prediction analysis. For time series analysis, so time series analysis is the best example of the prediction analysis, where for future, if you want to understand on the basis of sales of past years of past times, if you want to examine the future sale, so regression analysis will help to understand the future sale trend based on the past year's sales data, right? So in nutshell, we can say regression analysis is a statistical technique which is basically a dependency technique used to build a model where we can examine the relationship of one variable into the another variable, and we want to test the prediction or future prediction of the variables. Now let's try to understand different types of regression. So basically regression is of three types. The first one is simple linear regression. Second one is multiple regression or multiple linear regression, and the third one is logistic regression. So the first one is simple linear regression. Second one is multiple regression or multiple linear regression. Third one is logistic regression. Now let's examine what is it SLR, simple linear regression. So in case of simple linear regression, we say when there are two variables in a model, one is dependent variable and another one is independent variable. So in mathematical model, the simple linear regression is written as y equal to a plus bx. Now in this y is equal to a plus bx, y is dependent, y is dependent variable, y is dependent variable, a is intercept or constant, this b is slope, and this x is independent variable, right? So you can write this as a independent variable. Now let's understand this equation of y is equal to a plus bx. Now let's assume hypothetically some numbers, that y equal to a plus b into, so we are giving some numbers to a and b here. So y equal to, suppose this is 5 plus 2x. So as and when you will change value of x, you will get the value of y as 5 plus 0, y ka value equal to 5 plus 1, y equal to 5 plus, sorry, this would be 2 and this would be 5 plus 4, and you will see as a result this is 5, this is 7, and this is 9. As and when you will increase the value of x by 1 unit, so how much change is here? 0 to 1 and 1 to 0. This is 1 unit change, this is 1 unit change, right? So 1 unit change is giving you here 2 unit change in your outcome, 2 unit change in your outcome, right? That means, now suppose if you write this equation and try to understand this relationship between x and y, as and when you will increase x by 1 unit, your y would be increased by 2 unit, right? Now let's depict the same simple linear regression in a scatter plot or in a graphical way. So this is x, independent variable, this is y, that is dependent variable. If we plot this, so we will have a regression line or trend line like this, trend oblique regression line like this. So this regression line talks about the relationship between x and y. When x is 0, now see this, when x is 0, so y is equal to 5. When x is increased by 1 unit, 2 unit, so this is increasing by 2 units, 7 and 9, as per the equation that we have used, y is equal to 5 plus 2x. If you use this equation and if you plot this graph, keeping in mind these are the x ka value and these are the y ka value, 5, 7 and 9, right? So you will see 1 unit change in x will result 2 unit of change in y. So this is the depiction from this equation of regression, y equal to 5 plus 2x. As and when you will increase 1 unit of x, so you will get 2 unit change in the y, right? Okay, let's check this y equal to a plus bx equation for human behavior or social science. We are not having a straight line like this, right? This straight line depict, if suppose the equation is 5 plus 2x, right? As and when you will change x, value of x, you will get the value of y. Sorry, constant 5 and 7, then 9, right? So this is 5 and this is 0, this is 1, this is 7 and this is 2, this is 9. So as and when you will change the units, you will also get the change in your value of y, and you will get one straight line trend line, straight line trend line, trend line. But in case of social behavior, you will not find a straight trend line. Instead, what you will get? You will get like this, some scattered plot. I mean, your observations will not fall into one straight line. Rather than your observations will be scattered for this x and y variables. So in that case, first you have to draw a best fit line which represent all these observations. So, and this is the best fit line. So best fit line can be drawn based on the average, based on the the line which is basically depicting majority of the observations. And you will find that this straight line will also have certain observations. Some observations are beyond, and some observations are above the line, some observations are below the line, right? But actually this is the real depiction of social or human behavior with respect to two variables x and y, right? Okay, let's take an example, the same example where we were connecting the value of x with the value of y. Let's suppose this is an observation, right? This is an observation. If you want to check for this observation what are the value of x and y, and you will see for this particular A observation, this is the x1 and this is the y1, right? But this observation is telling you about the true depiction of the data. So that means the true value of y is represented by this x1. However, the estimated value which is being drawn by this trend line is telling you the different story of y, that is this one, and this estimated y is known as or represented as y hat. So y hat equal to estimated value of output, however y equal to actual or a real value. So this, okay? Okay, now what it means, the difference between this, this actual to real, this gap is error. This is the error which is being depicted by this trend line, or this line is also known as regression line. So the mathematical modeling or statistical modeling for social or human behavior related models are basically depicted with y equal to a plus bx plus error, right? And generally y hat equal to a plus bx. So you will see y equal to y hat plus error, or we can say y equal to, or y minus y hat equal to error, right? So estimated value, this estimated value means the value which is basically being set by regression line, which is nothing but the representation. This is the representation. This is not the actual. This is not actual observation, right? Actual observation is y. So whatever is the difference between y minus y hat, that is difference between actual and estimated is error, right? So whenever we will write the equation for social or human behavior, our equation will also have one error term, right? So this is the depiction of statistical modeling for simple linear equation. This is the depiction for simple linear equation. Now, simple linear regression, when we are moving towards multiple linear regression from simple linear regression, so the difference between these two techniques is basically depending on the number of independent variable. In case of SLR, we have one independent variable. In case of MLR, more than one. So how can we depict the MLR? Multi-level regression can be depicted on y equal to a plus bx1 plus cx2 plus dx3 plus error term, right? So in this equation we have utilized one dependent variable, that is y, and x1, x2, x3, three independent variables. A is intercept or constant. This B, C and D, B, C, D, these are the slope, right? And E is equal to error term. Now let's try to understand the interpretation of this equation, multiple linear equation. Y is equal to a plus bx1 plus cx2 plus c dx3 plus test, I mean number of other variables plus error, right? Multiple linear equation. I wanted to connect this equation with one hypothetical example. Keeping y is equal to GDP, a is a constant, plus b is a slope, x1 is national income, right, plus c, x2 is FDI inflow, plus d, suppose, is remittances received from abroad, remittances received, and there are only three independent variables plus error. What it means, and suppose the value of a we are assuming here is 10, and this 10 is 10 lakh, okay? So that means if we are putting national income as 0, there is no national income, right? In that case, you will see, even if there is if ni is 0, if there is no national income, if there is no FDI or FDI inflow is also 0, and if remittance is also 0 for a country, just an hypothetical situation, right? In that case, the GDP of that country will also have certain value. What it means? It means that this value is because of there are some other factors other than these three factors which are also responsible for GDP contribution, right? Okay, just take an conceptual model for the same model. So this is the GDP. What we wanted to show, GDP is depending on three independent variables: national income, second thing is FDI inflow, and remittances received. So this is the depiction of your conceptual model, right? and this is the mathematical modeling of this model. For social science studies. Okay, so this is multiple linear regression. Okay, now when you are trying to work out when you are utilizing some statistical software, because nowadays it's very easy to calculate the analysis, and it is the power of machine that any software you will easily get, and all the software will provide you the results. So how to interpret, let's interpretation of regression. Interpretation of regression. Once you will have interpretation of regression, once you will provide the data of dependent variable and independent variables to the software package, right? So software will provide you some tables like this, and this table will have the value of constant, your independent variable 1, independent variable 2, if independent variable 3 or more if any, then coefficients, then it will have t statistics, and it will have p value, means level of significance, okay, which is usually 5% or 95% confidence interval, right? So 5% hello means 0.05 is the significance value p that you have chosen for your hypothesis testing. Now the value of constant, variables and the constant. So constant, this you will see this kind of table. So the first value you will see for the constant, for this constant coefficient. So this constant coefficient is nothing but, if I connect it with an example, 10 plus 2x plus 3x2 plus 4x1 plus error, right? If I connect you with this hypothetical example, just give me a hypothetical example, so you will see this 10 is nothing but the coefficient constant, this 2 is nothing but the coefficient of x1 variable, this 3 is coefficient of iv2, this 4 is coefficient of iv3. Now see, for these value the machine will calculate you some t value, t statistics. If you remember the hypothesis testing, these t values are nothing but the value that we have drawn from. If you remember, these t values are basically taken from t calculated and t critical, right? So t statistics will be provided by the machine, and based on this calculated value, because this is the calculated value, these are the calculated values, computer or machine will also provide you the p values correspond to this, right? Suppose the p value is 0.05 for constant, 0.03 for constant, 0.148 for iv3. So this means that at 0.05% level significance, the value which are less than 0.05 are significant. So this is significant, I mean constant is significant, iv1 is significant, iv2 is significant, but iv3 is not significant, because this value 0.148 is greater than this 0.148 is greater than 0.05, therefore insignificant. Okay, so this is the interpretation of the table. So on the basis of this model, we can say that y is depending on x1, x2, right? Not x3, not on x3. So x3 is this relationship is wrong, however these two relationships are significant. So this prediction of y depends on x1 and x2, not in x3. Now one more analysis we have, that is logistic regression. Logistic regression is one of the technique where we are utilizing categorical variable as dependent variable. So categorical variable is dependent variable largely when we are having answer of y in yes or no. That means if our outcome variable is taking two answers or two response, yes or no, or agree or disagree, right? So in such cases we use logistic regression rather than simple linear regression. In case of simple linear regression and multiple linear regression, we use metric data, that means on continuous scale. So this is one of the difference, or one of the important point to note it. If we are having continuous scales, I mean the data is into the metric scale or in a continuous scale, we will only use SLR and MLR. But when our data is in categorical variables in form of yes or no, or response is in the form of yes or no, or agree or disagree, so in that case we will use logistic regression, right? That's it. Thank you.